All right, guys, this is my final video for you. I promise I will not be gone the rest of the year, the rest of my life. I'm going to stay in school. I promise. Well, I might not be able to hold on to that one, but so today, the objective of today is to understand the relationship between the peak force, the time it acts over, mass and velocity, impulse momentum, and then especially being able to use a force versus time graph to use the integral to determine the impulse, which is also the change in momentum of the system. So there's really three things that we'll be doing today. And so here it is. We will do the pre-lab for the impulsing a dynamics cart. And then on Monday, when I return, we'll do that lab. And then practice problems 1 through 4 will also be due, and we'll go over those on Monday. And then I'm going to show you on the last slide, I have the quiz corrections, and I'll go over how you can do that and get those turned in. Okay, so just kind of scrolling down. Again, here's those notes that you can go through. This is the link to the practice problems. You can also get there from Classroom. Just a quick reminder, the impulse momentum theorem. So again, impulse is the net force times time, and momentum is mass times change in velocity. So, or the change in momentum is mass times change in velocity. Okay. And again, here is a force first time graph. And if we look at the area under the curve, the integral, that is our impulse. We could also say it is our change in momentum. So if we look at this one right here, just know that again on these slides where you have questions, I really would like for you to open up your notebook and work these out, and just come up with your answer before looking at what the answer is. And so the answer is provided in the speaker notes. So if I come down here and pull these up, you'll see the answers to these questions. But you're looking at this ball hitting a force plate, and it shows you the amount of time that happens over. And first question, just describe the change in momentum in terms of magnitude and direction. And then is there a net force involved, and explain how you know one way or another. Okay. And then this slide here is just showing how there is a change in momentum and kind of graphing the impact force over time, and what that looks like. This slide here is showing you a pretty important thing, that if you take the average force, this yellow that pops up here, if you take the average force times the time, that is the yellow area, which is going to be equal to this red area here. So the area under the curve, the impulse or the change in momentum, is just going to be your average force times time. Coming over here, again, you saw this slide last time. Basically, if you extend the period of time that the force is exerted over, it will be a decreased force for an extended period of time, so you won't get near the damage here. This is just showing that, and we've done this before, that you can use geometry to discover what the area under the curve is. And so A1 is just going to be your force times time. A2 is going to be your force times time divided by 2. So your 1/2 base times height. Coming over here, this is a little bit more intricate. And so for this one, you need to count the squares and partial squares for each and every one, which is a little bit time consuming. It's a little bit messy. It's nice to have a program like on the next slide that will do it for you. So I went too far. So when I return on Monday, I'll go over this one. I have a force plate. I'll show you me jumping on the force plate and how it'll calculate the integral right there and show you the change in momentum, which is the impulse. Work your way through these. All the answers are in the speaker notes, so you can see the questions here. Just work yourself way through these and check your answers, and just make sure that you're doing fine. There's not too many of these problems, but I do think they're beneficial. looking at Newton's cradle, you've all seen this before where it bounces back and forth. If it were a closed system, it would go on forever. Clearly, it's not a closed system. It will eventually stop. So what makes this an open system? So then we get to the Impulsing a Dynamics Cart Lab. So if you click on this link, it will take you here. And I added in here that you'll do this part over here where it talks about impulsing this roller cart here. You'll do this in class on Monday with me. But for now, you can use the graphs that are already there that are embedded in there for you, and just use these to answer the questions. Just answer down to where it actually gets to. I'm sorry, when it gets to this part right here. So impulsing a dynamics cart, from this part down, we will do on Monday. But if you could have this section here done for Monday, that would be awesome. Coming back here, this slideshow kind of walks you through a lot of what was on there. So coming here, it talks about how I will demonstrate it really quickly for you on Monday, and then you'll do it. This is talking about just that you can exert a large force for a short period of time, medium force for a medium time, or a small force for a long time, and bring them up to the same velocity, and they will travel the same distance because they will have the same velocity. This is showing the integral of that large force for a short period of time. This is showing the integral of a more moderate force for a longer period of time, and then a small force for an even longer period of time. And then this gets into the impulsing of the dynamics cart. Again, we'll do this together on Monday. Just kind of come all the way down here, and then we get to the quiz correction. So if you open up the quiz, you will see which ones that you missed. If there's something wrong with how I set it up and you can't see which ones you missed, please let me know. I'm sure one of you will send me an email, and I'll get right back to you and make sure that you are able to access that. But all you have to do is look at the ones you missed. Identify that question in some way. They're not numbered and they're out of order, so please make sure that I know what the question is. You don't have to write out the entire question, but write it in such a way that I'll know which question it is. Identify what your original answer was, and then what the correct answer is, and then have that for Monday for me. You can do it in your notebooks. You can submit it to me, share it with me, or you can just wait till Monday and hand those in to me on Monday. So that's it for today. Again, I do apologize. I do not want to make any more videos. I want to be there with you. And I promise Monday will be a little bit more of an exciting class. So have a great one, guys. Enjoy your weekend. Stay safe and healthy, and I will see you on Monday.